So this chapter seems to be a little all over the place. What I want to do now is talk a little bit about what are called arithmetic sequences. They seem to be not connected when we first start mentioning it, but you'll see eventually how they get connected. An arithmetic sequence is a sequence in which each term differs from the previous one by the same fixed number. We call this the common difference. So, give you a quick example of how that's going to work. Let's take the sequence 1, 5, 9, 13, and 17. Now, to find the common difference, you find the difference between the terms of the sequence. The long technical way is to go 5 minus 1 equals 4. 9 minus 5 equals 4. Many people call this T2 minus T1, or and then T3 minus T2. So sequential terms in the sequence will have a difference, a common difference. 13 minus 9 equals 4. 17 minus 13 equals 4. As you can see, this does have a common difference. In this particular situation, you end up with what's called an arithmetic sequence. Now, that can increase or decrease depending on the situation. For me, what I do normally is I do it quickly. I just go like this. Okay, what do I got? Oh, 4, 4, 4, 4, therefore arithmetic. Okay, that's all you have to do. That does it just as well. Now, another part that comes along with this is we're going to say that U1, so term 1 is 1. Term 2 is 1 plus 4. Term 3 is 1 plus 4 plus 4. Term 4 is 1 plus 4 plus 4 plus 4. Now, why am I doing this? What's the big deal? Well, first we'll move this down a bit. It's leading to this little formula that we get. Now, notice the connection here. This is 4 times 2. 4 times 3. This number is connected to this. This is 4 minus 1. 3 minus 1, and so on. And it'll work that way for every one. So, if we have a general situation, UN is equal to U1 plus n minus 1. So fourth term, take away 1, we get 3. Well, that would be that. Times d, where d is the constant difference. I prefer, and it's okay if you write it this way, this also works. Instead of using u, tn equals term 1 plus n minus 1 times d. It's the exact same thing, just written a little differently, and it's all a matter of the textbook and for the symbols that they're going to use. Now, this little blurb down here states all the same stuff we just did. How does it work? We have a sequence here. Shows that this sequence is arithmetic. What I would do is write it out. 9, 15, 21, 27. 3 to 9 is 6. 6. 6. 6. Common difference of 6. That tells me it's arithmetic. Formula for the general? Well, we have un equals u1 plus n minus 1 times d. D equals 6. This is u1, u2, u3, and so on. So un equals 3 plus n minus 1 times 6. I personally would leave it like that, and you can easily do that. Or the other option is you can simplify this, and I'll show you. Un equals 3 plus 6n minus 6. So un equals 6n minus 3. This and this, same, and either is okay. Okay, now that we have a general form, find the 100th term of the sequence. 100th term. 100th term means n equals 100. So u 100 equals 6 times 100 minus 3 equals 597. U 100. That's it. That's all you have to do. Now, 489 and 1592. 489, 1592 equals un. Equals un. We have to sub these in and see if they're part of the sequence. So 489 equals 6n minus 3. Add 3 to both sides, I get 5. 492 equals 6n. Not doing that in my head. So 492 divided by 6. 82 equals n. Part of sequence. Beauty. It works. 1592. So 1592 equals 6n minus 3. 1595 equals 6n. So 1595 divided by 6. 265.8 equals n. 83. Not part of sequence. So that's all there is. We're going to make use of the arithmetic sequences, figure out how they work, how they don't. And are we going to do that now? Yep. This video is getting really long. Find k given that k plus 1, minus 1, and 2k minus 1 are consecutive terms of an arithmetic sequence. And hence, find the terms. So we have k plus 5. Negative 1. And then we have 2k minus 1. Well, d is going to equal negative 1 subtract k plus 5. Okay, so this subtract this. Well, the same is going to work for this. D is also going to equal 2k minus 1 subtract negative 1. Simplify a bit. D equals negative k minus 6. D equals 2k. Slide that down a bit. Make them equal to each other. 2k equals negative k minus 6. 3k equals negative 6. k equals -2. Now that we know what k is, we get to sub it in and figure out what these terms are. -2 plus 5, 3. -1. 2 times -2 minus 1, -5. So, change of 4? -4 ends up being our D value. And it works. Perfect. So there's lots of uses for an arithmetic sequence. Next up is going to be geometric sequences.